Assalamualaikum and good morning to Puan Srita. I am Mr. Chai bin Mawan Najib. Matrix number 1060 is today is going to be presenting for our presentation work for topic 3 matrix and variance covariance propagation. So the meaning of variance is a value by which the precision is given for a set of data. Variance is also known as the mean of the square of errors. So next is covariance, which is the correlation between two unknown variables. If the covariant value decreases, the correlation of the variable also decreases. And lastly is properties of variance covariance matrix, which first all the properties are symmetric matrix. Second is determinant of covariance matrix should not equals to 0, because and for the third one is all diagonal element in covariance matrix must be positive. So for this question one, we were given an equation which is latitude equals to distance cos with azimuth and departure which equals to distance sin azimuth. So for this question one, each of the students were given a different amount of length and azimuth or distance and azimuth, so that our answer may differ. So that the question asks for us to calculate the latitude and departure. So this is my answer. So first things first, if we want to calculate the latitude, we will use the equation that is given before, which is distance cos with azimuth. So we must insert the distance, which is also length, which is 156 meters, 156.87 meters, and cos it with 20 degrees, 35 minutes, and 36 seconds. So which we will get the answer of 146.899. So next we will have to find the derivative of let respect to d or distance, which is cos azimuth. This equation is given also on the question, which it gave latitude respect to d. So the answer is 0.936117519. In survey adjustment, it is not recommended for us to. It is not recommended for us to. It is not recommended for us to round up the answers. So we'll leave it as long as it's good. So next, we will have to use the equation of derivative let respect to azimuth, which is we will change the distance to negative 156.87 and then sin it with the azimuth, which we will get the answer negative 55.169194. Okay. So finally, next we will have to substitute it into a nonlinear equation. So we will take the answer from derivative let respect to d, which is 0.936117519. We will have to power it to 2, and then we will have to add it with the multiplication of the answer of latitude respect to AZ with 0.000043 and something, which is we will have to change from degree to radian. So the final answer that we will get is 0.019. So the latitude is on 146.849 plus minus 0.019 seconds. And so for the next, which is we will have to calculate the departure. The equation that was given for departure is distance since with azimuth. So like the previous one, we'll have to put the distance sin with azimuth, which is 156.87, sin 20 degrees, 35 minutes, and 26 seconds. So the answer will be 55.169. So next, we will also use the equation that was given in the question, which is derivative of depart with respect to d, which the equation is sin azimuth. So the answer will be 0.351687346. And then next one is we will use derivative of depth, departure, respect to azimuth, also same as previous, but the difference with derivative departure respect to azimuth with derivative of latitude respect to azimuth is that we will use cos instead of sin. So the answer will be negative 146.8487553. So and then we will substitute it into a nonlinear equation. So that the final answer that we'll get is 0.0095. So the answer to departure that we will get is 55.169 plus minus 0.0095 seconds. And also, like previous, in the nonlinear equation, we must change it from degree to radian and multiply it with the answer that we get from the derivative of departure with respect to azimuth. So in this question too, everyone is given the same question, and this question is asking for us to find out what are the corrected elevation difference and its estimated error. So we were given the equation below. So I proceed to my answer. So this is the answer for question number 2. So the equation that was given is hi plus slope distance cos with z or zenith plus cr, which is given 0.0675 times multiply with uh, slope distance sin with zenith divided by 1000 to the power of 2 and minus hr, or known as prism height. So after we insert in all the numbers, which is 5.12, which is instrument height, plus 1256.78, which is slope distance, cos with 88 degrees, 13 minutes and 15 seconds, which is zenith, plus 0.0675 or CR, and then minus with 6.78, which is, so the answer that we'll get is 37.466. So next we will find the differentiate of z. So the equation is which is 2 multiplied by 5 to the power of 2 and add with 0.3 to the power of 2, which is 5. We will get from the digital reading accuracy, and 0.3 is vertical compensator accurate to within 0.3. So we will use both of that, and the answer that we will get is plus minus 7.1 seconds. So next we will try to convert 5 mm, which we will get 0.1064 feet. So for the equation of estimated error distance, we will use 0.005 to the power 2 plus with 0.01 to the power 2, and we'll take the convert of 5 mm, which is 0.1064 to the power 2, and then we'll have 5 multiplied with slope distance divided by 1 million and to the power 2, and we will square root the answer, which we will get 0.0221 feet, 21 feet. So for the differentiate of the difference of h, we will use differentiate of hi, which is instrument height to the power of 2, add with hr, or prism height, to the power of 2, and then we'll have cos zenith plus cr slope distance, and sin to the power of 2 with zenith divided by 500,000 to the power of 2. And then we'll have it add with CR, slope distance, sin to the power of 2 divided by 500,000. And lastly, which we will cos with zenith minus sin zenith, and then we'll take the answer of differential of z just now, which is 7.1. So we'll divide it by p, so to the power of 2. So, and finally, after calculating all of that, the final answer that we will get is 0.04 feet. And so that is the answer for question 2. So in conclusion, after doing both of the tasks that was given, I think now that my understanding of the topic is becoming better, and that, for example, I get to solve on how to answer the question latitude and departure, which is different from everyone, but after I studied a bit and understand it, I know how to solve it. And for the question 2, which is quite a bit complicated, but after giving it a more thorough, more through effort, I can also answer the question 2. And I think that is all for my presentation. Thank you very much.